All right, this is target 7B, and this is day 1. So we're going to take a couple of days to get through this. This is solving systems. Now, yesterday we learned how to write systems and write the equations that went with them and define the variables. Today we're going to learn how to solve them by one method. All right, so just as a recap, a system of linear equations is when two linear equations, so they have an x and a y, work together when graphed on the same coordinate plane. So let's say that was one equation as a graph. This is another equation as a graph. And if you put them together on the same one, you would end up with this. Okay? And basically, the solution would be where the two lines touch or where they intersect. Okay, so, and that would be your xy coordinates. So we're going to be solving for xy. And if you were to graph it, your solution for x and y would be that point at which they intersect. All right, so there's a couple methods for solving linear equations. One method that we're going to be getting into the next time you have a video is graphing. And it is easiest when it's in slope-intercept form. You can see here where a solution would be if it has one solution, because there's basically three possible outcomes with linear equations. If there's one solution like here where they intersect at one point, there's no solutions, and you can tell this because their slopes would be the same and they would be parallel and not intersect, so the lines would never cross. And then there would be infinite solutions where the lines basically lie on top of each other and it's not as apparent from the equations that you have, but once it's kind of simplified everything and solve for x and y, you would find out that they were in fact the same line. Okay, another method is elimination. And that is when you have your x and y on one side by itself and you're set up like an equation like you're used to seeing. So with one solution, x will be a number and y will be a number, and you'll write your answer as coordinates, x comma y in parentheses. Very important. If there was no solutions, you would end up with something to the effect of like 0 equals 3, okay, which is not true. 0 does not equal 3. So that would be no solutions. Infinite solutions would be if you ended up with a true statement, such as 0 equals 0, because 0 does equal 0. So that would be infinite solutions. Today we're just going to focus on elimination. So you might want to write this graph down. I know it's a lot of writing, but this will be very, very helpful to you. This is best to use like here where you have, your two equations, and you could cancel these out. You've got a positive 3x and a negative 3x. Because basically what we're doing is we're adding these equations together. So to solve for the variables, you do it one at a time and you get rid of one of the variables. So this one would be like a very straightforward one where you can just say, okay, I'm just going to add the two together. You may have to multiply one or both of the equations in order to solve for x or y, but we'll get into how to do that. And again, we went through what one solution, no solutions, and infinite solutions would look like. All right, so the goal of elimination, like I said, is to eliminate one of the variables. Okay, you do this by adding the opposites so they cancel out. So you've got to make sure that they're opposite. If it was a positive 2x on the top and a positive 2x on the bottom, you would have to do a step in order, prior to adding them together in order to get rid of them. Because 2x and 2x equals 4x. It doesn't equal 0, and you want them to equal 0. Okay, doesn't matter which variable you eliminate first. You can choose whichever one you want, but I usually go with the one that's most convenient to work with. All right, so let's look at these examples, and I would write down each one of these because each one of these does something a little bit different. So let's say we have to solve the following system of equations. Well, we've got 3x minus y equals 7 and 2x plus y equals 3. If you look, you have a negative y and a positive y. So you wouldn't want to get rid of your x's first. You'd get rid of your y's because you can just say, I'm going to add these two together. The y's are going to cancel out and leave me with 5x equals 10. And then you just solve like we've done pretty much most of the year. Divide both sides by 5. 5's cancel out on that side, and you end up with x equals 2. Now what we do is we take that x equals 2 and we plug it back into either equation. Doesn't matter which one. I'm going to go with the second one. And so where you see that x, we're replacing just the x with whatever it equaled, in this case 2. So 2 times 2 plus y equals 3, which gives you 4 plus y equals 3. Subtract 4 from both sides, and you get y equals -1. So your solution would be 2, comma, -1. Remember, x always comes first. It's not the first one you solve for. X is always first. And then you're going to want to check it. So basically, you want to plug those numbers in. So like we did, like I showed you on this calculator screen here, 3 times 2 minus -1. Now what's important is this is minus and this is -1. So it's a minus -1, which is actually a +1. So 3 times 2 is 6, plus 1 is 7. And then you plug it into the other one because you have to make sure it works in both. Because you may come up with an answer that works in one but not the other, and then that's not a solution. So 2 times 2 is 4, plus -1 is 3. It works in both. That's the answers that we're given. All right, so now here's a bit of a different situation. Now there's a coefficient in front of both of them. But if you look and we add them together, we still have a -3x and a +3x. So they still cancel out and equal 0. So that'd give you, when you add your y's together, the 2y and -7y gives you a -5y. And then you have to add together what's on the other side of the equal sign too. 17 and -37 equals, oops, going the wrong way there, equals -20. Watch your signs here. Be very, very careful. Okay, so divide both sides by -5. The -5's cancel out. The two negatives on the other side cancel out, so you end up with y equals a +4. Now you're going to plug that 4 in to either equation, and you're going to do it for y this time. So you've got, I'm going to use the top one this time, -3x plus 2y equals 17. So I'm going to replace the y with a 4. So -3x plus 2 times 4 equals 17, which is -3x plus 8 equals 17. Subtract 8 from both sides, and you get -3x equals 9. And then divide both sides by -3. And you get x equals -3. So your solution, even though we solved for y first, remember x comes first. So -3, 4 in parentheses. And again, you should check your work. I'm not going to go through each one and show you, but you should check your work. So now in this case, let's look at this example. So we've got 4x plus y equals 10 on top, 3x minus 2y equals 13 on the bottom. So if I add these together right now, nothing is going to cancel out. So you can choose to get rid of the x's or the y's. It would be easier for me to just get rid of the y's because all I would have to do then is multiply the top by 2, because that would give me a +2y. Now because I'm multiplying the top by 2, and the reason I'm doing that is I need the opposite of this -2y. I need this to be a +2y. So because I'm multiplying it by 2, I have to multiply everything by 2. So 2 times 4x is 8x. 2 times y is a +2y, and 2 times 10 equals 20. And then you write the other equation exactly how it is, because we're not changing that. So we add them together now. The 2y and the -2y cancel out, which gives you 11x equals 33. Divide both sides by 11, and you get x equals 3. Okay, so now just like before, we're going to go ahead and plug in 3 for x. So I'm going to go with the top one, and you can do it before or after you multiplied by 2. I'm going to just do it before I multiply by 2 to make it easier on myself, smaller numbers and all. So 4 times 3 plus y equals 10, which gives you 12y. 12 plus y equals 10, minus 12 from both sides, and you get y equals -2, so your answer is 3, -2. All right, yet another example. So we have, again, we have a system of equations, 2 equations. 4x minus 4y equals 20, and 3x minus 4y equals 15. Now you might say, oh, well, I can just put together, that one's easy. However, you have a -4y on top and a -4y on the bottom. So if you added them together right now, it would be -8y. So we need to find a way to make one of those positive. And the way that we do that is we multiply by -1. So really all we're doing is changing the signs of each part of the equation. So it's a negative 4x, a positive 4y, and a negative 20. And then the bottom one stays the same. Now when we add them together, the positive 4y on top and the negative 4y on the bottom cancel out. Gives you a negative x, because negative 4 and a positive 3 is a negative 1. So I just write negative x, or negative 1x, whichever you prefer, equals negative 5. Now, to get rid of the negative, if you change the sign on one side, you have to change the sign of everything. So you divide by negative 1, or you can just say, you know what, I'm just going to change the sign. So x equals 5. And then again, plug that in for x. So 4 times 5 equals, or minus 4y equals 20. 4 times 5 is 20. Minus 4y equals 20. Then you subtract 20 from both sides, which gives you negative 4y equals 0. Divide both sides by negative 4. 0 divided by negative 4 is 0. Okay? So your solution would be 5, 0. All right, last example. So we've got 3x minus 3y equals negative 9. And we have negative 4x plus 5y equals 8. So you look at this and say, well, I've got a 3x and a negative 4x, so that's not going to work, because if I add them together, that's negative x. And then I've got a negative 3y and a positive 5y. If I add those together, I'm going to end up with 2y. Okay, so what do? Well, like in one of the previous examples, you're going to have to multiply you're going to have to multiply an equation by something. But because we can't get rid of one of them by multiplying just a single equation, we're going to multiply them both. So because I'm going to get rid of my y's. You could get rid of your x's if you want, but because I'm getting rid of my y's, see how you've got this positive 5y here? You put the 5 up there. And then you've got this negative 3y, but I'm going to make this a positive 3 because I want the signs to stay the same. If I multiplied this by negative 3, this would become negative and they wouldn't cancel out. So if the signs are different, multiply them both by positive numbers. If they're the same, multiply one of them by one of the negative numbers. Doesn't matter. All right, so I multiply the top. 5 times 3x is 15x. 5 times negative 3y is negative 15y. 5 times negative 9 is negative 45. And then the bottom, 3 times negative 4x is negative 12x. 3 times 5y is 15y. And 3 times 8 is 24. Now your y's cancel out, leaving you with 3x, because 15x minus 12x is 3x. And negative 45 and 24 is negative 21. Divide both sides by 3. You get x equals negative 7. Now again, we're going to plug that in for x in either equation. So I'm going to go again with the top one. 3x minus 3y equals negative 9. I'm going to plug that in for x. Okay, so 3 times negative 7 minus 3y equals negative 9, which gives you negative 21 minus 3y equals negative 9. Add 21 to both sides. You'll get negative 3y equals 12, and then divide both sides by negative 3. You get y equals negative 4, so your solution is negative 7, negative 4. Now, I know that's a lot to take in, so we are going to, obviously have, practice in class. Ask questions if you get confused. Please ask questions. I will help you. It's a lot to take in, and this can be a complicated concept. So here's some tips, though. When you have to multiply an equation to use elimination, make sure you multiply all the terms in the equation on both sides of the equal sign. I can't tell you how many times I see people only multiply one side. You've got to multiply the entire thing, both sides of the equal sign. And do not forget to check your solutions to make sure they work in both equations. That's the easiest way to determine if you have the right answer. If you check and it doesn't work in both, you made a mistake somewhere, so backtrack. Don't be lazy. Don't say, you know what, forget it, I'm just not going to do it. Just go back and do it over again. It's better to get it right and to put a little bit of extra work in than to just give up. So, again, ask questions if you need help. And I am out. Sorry this got to be a little long.